This is like kind of old review, but you know, whatever. So I think that there is something that I want to do. I think is it import differential? I forget what the hell this is. Yeah. How do you do it? You do this. I don't know how to use this. Honestly, I think this is all a bunch of baloney. I probably should use tech because if you ask ChatGPT to generate Typst code, shit sucks. So stupid. Need to come up with a prompt or something. Anyways, let's just do this because I really couldn't give a shit. Um, okay, so we have to do section 2.3, 7, and 9. So I'm going to do this all in one go. Um, and then we're just gonna I'm just gonna copy and paste it later. Okay, so we can just do this page break or something like that. All right, we can get started. Actually, I'm just gonna do this. I don't give a fuck. That's what I fucking thought. So we're doing 7. Okay, so 7. Show that the harmonic oscillator uh can be scaled. That the harmonic solutions can be scaled and still be solutions. All right, so all right, so let's do this. How about that? And then I guess we do need to kind of see it. Maybe I don't know. I've never done it like the top half. Can you even do the top half? All right, I don't give a fuck. We'll just do this thing. All right, so how do we do this? It's like God, I hate this thing. It's like M, and then how do we do this? dv, but then is it actually even faster? I forget because you have to put this deg2 in it. So it's gonna be yt. Is there some weird? Oh, you can just do deg2. There you go. Plus b dv yt plus k y is equal to 0. Okay, so we have this. So wait, let's just do this. I kind of fucked this up. Harmonic oscillator. Hey, show. Wait, can we just copy it? I actually want to hurry this quickly because this stuff sucks. All right, so okay, so suppose y of t is a solution. Now we can replace y of t what c times y of t for c and r. Oh wait, you gotta do bbr. All right, so what does that mean? That means that this means that dv y of t is going to be equal to, actually, how do we do this? How did I do this the first time? I don't remember. We have Well, isn't it just gonna be that like it's gonna be like C times this doesn't seem right. Let's try to do it on the board. What? Right. So we get okay, so then comes m times m s squared e to the st. We really don't need this. Plus b s e to the st plus k sy. And this, but this needs to be e to the st. Wait, but this doesn't have the s there, right? Yeah. Okay, so then that comes right, but all right, are we really gonna do the freaking so it's gonna be what? S is equal to minus b plus is there a PM? How do you do this? PM plus minus. You really gotta type that in? That's so annoying. Plus thumb. Minus b plus or minus square root. Square root. Wait, how do you do it? Square root. You say square root. What happened? Oh, but you do it with parens. Oh, I get it. Okay. You gotta do square root. Okay, cool. What was this? This is gonna be b squared minus 4 times m 4m k divided by, I guess I need, does this work? I don't even know if this works. Be like this over 2. Is that right? Okay. Uh, but how does that give us the general solution of the differential equation? Okay, so this forms the general solution of e to the s2 for the solutions of s. Now we can replace y of t with a generic constant multiple of c and r, such that y of t is equal to c e to the st. Okay, so now we get that. So let me just double check. I like to double check these things a little bit. So let's just do d c times c e or e to the. Is that right? I think we just do x s t s. No, wait, t, right? Yep. And then we do it t 2. Yeah, that's what I thought. So we should be able to just copy this. Let's go to C, C, C. So then we get this bad boy. This is gonna take forever, man. Okay, so we get MC C C. We can do C. Okay, so this means the easiest way is to know that a linear differential, that a linear homogeneous differential equation has solutions that form a subspace, a vector subspace, and therefore is closed under scalar multiplication. But the hard way is am I still live? Is this actually working? Oh yeah, it is. It's fine. Okay. So we get this CE to the ST. How does that show that this is still a solution? That it's still a solution. Ugh, it's so annoying having to do this all the time. MB. Okay, it's like, ugh, just so tedious, man. Yeah, I didn't need to do all this. This is so ridiculous. Should I rewrite this? Should I start over? Yeah, start over. Yeah, why not? Why not? Who cares? Okay, so we assume that y of t is a solution. That this means that is satisfied uh, for all. Now we define z of t equal to c times y of t. Actually, you know what? Hold on. Wait, let's copy this. Let's just leave all the other junk in there, right? Why not? How do I put the equation number on it? Equation number. How do I number it? It's like so verbose. I just want to put the number 1 next to it. Oh, you know what I think I can do? Can't I just do like something that like right aligns it? Isn't there like a right? Forget. See, that's terrible. Alright, let's just look at it. There's something that Oh, wait, what? This is gonna be weird. Oh, really? But what if I only want it on this one? That's interesting. I definitely don't want that. Oh, here you go. Perfect. Oh, but you gotta do this whole thing? Wow. That's crazy, man. But that's okay. I don't really care. We do this. And then we do... And we get the one there. That's good. And then I just put this like that. Oh, isn't that nice? Cool. All right. Satisfies. Uh, can I refer to it? Like hash eq? How do I refer to an equation now? Huh. You can say let harm os. Can I do that? What? Let. Oh, no, that's not what I think it is. That's silly. Yeah, that's not what I wanted at all. All right, we don't really need to bother with this. I just kind of wanted to see what it was all about. Satisfies one for all t. Then we dude, I have so much to do. I don't even know why I'm spending so much time on this. Okay. We get oh, I hate that. I just want to copy this. And we get m. It's gonna be z, which is equal to, we get, which is oh yeah, we gotta do this. We get c, oops, c, y, c, y. Oh, and then here, this is a z. And then this is a k, c, y. Then we can get c, and then we get this. But it's just that, not that. This is like that. Okay, is there a QED? Is there like a black box? QED? Oh, nice. That's cool. Since, all right, that's enough of that. This one should not have taken so much space. Okay, so let's just keep going. That was ridiculous. I don't know why I did all that. Cool. All right, number 9. That was crazy, man. I don't know what I'm up to. I'm up to some wild stuff. Okay, this one's good. Oh, we should do this one again. Yeah, I forgot about this. Okay, so I remember doing this one. This one was so good. Oh, but I do forget the trick. There's like a trick to it. I forget exactly what it was though. Okay, so let's do this thing. So we got the harmonic. Okay. So how do you do this one? We're trying to make I always just have to just rederive the whole thing, but I should have eaten something, dude. I haven't eaten something in so long. All I had was carrots. Carrots and lettuce. Wait, K is this. Wait, I'm so confused. Wait, isn't B the damping? Like if you get B is the damping, but oh yeah, no, that's right. Okay, that makes sense. Yeah, yeah, yeah. Damping is on the velocity, but the force is on the position. But x equals 0. So if we have, I mean, okay, to derive the if we just want to derive the single spring, we have to take two laws into account. We have to take the force is equal to the mass times the acceleration. That's just Newton's law. Okay, this is equal to F is equal to m times y, or let's say x double prime. Okay. Oh wait, how do you? We can just do this. Okay, but we also know from Hooke's law that the force acted on by a spring is equal to kx, right? So in that case, we get k kx, or let's do this. Mx double prime, oh my goodness, is equal to kx. Okay, well, this is with no damping. I hate that you have to put these here. Actually, do you have to put them here if you do this? Yeah, you do. It's just so hard to do that. Okay. But the problem with this is that this is relative to 0 because we assume that the rest position is at 0. But the rest position is not at 0. So if L1 is the rest position, then the force is going to be mx double prime is equal to k times x minus L1, right? Because if L1's here and we are x is greater than that, then the force, wait, if in the, no, so I'm pretty sure it's actually L1 minus x. And then similarly, but we also get the force, but so then for the other pendulum, or for the other oscillator in isolation, we want this. Oh, wait. Actually, did I do this wrong or right? I always get the signs confused because if um if acceleration is positive, that means it's going to the right, right? So that means that if x is past this equilibrium point, then this will be negative, and the acceleration will be going to the left. I think that's right. Then for this one we're gonna get, but it's gonna be x minus L2, I believe. So then this is in isolation, but that means that the sum of the forces acting on it. So it should be that this no damping, but coupling the coupled. This is going to be like this. Mx double prime is equal to it's just going to be this plus this, right? Am I crazy for thinking that that's what it is? Oh, but this is going to be, we have to be careful because this needs to be K1 and this needs to be K2. So then we get K1 here, K2 there. Oh my god, is it really almost 8? So what's the 0 going to be? If we just factored this, if we just multiplied this, we get K1 L1 minus K1x plus K2x minus K2L2. And that's, I'm just trying to find out what the equilibrium point would be, really. I think it'd be in the middle. Okay, but so my guess for what the whole system would be you have um mx double prime plus bx prime minus, yeah, bro. What's up, man? How's it going, dude? Typist is cool-ish, but I also just kind of hate writing documents like this in general. So it's like not that fun for me. But yeah, it is nicer than tech though. So that's cool. Dude, I found the freaking, I mean, I got a bunch of stuff due at like midnight, but this guy, Tom7, bro, I've been obsessed with this guy, bro. He is the fucking coolest guy ever, man. His videos drive me up a wall how good they are. Dude, I was crying laughing this
It
morning.
has come
I
to
don't want
my
to
attention.
steal his joke, but he's talking about Donald Knuth writing The Art of Computer Programming, and he's like, I don't know. He has this joke about the deadline, dude. I was dying. It's so funny. Oh my god. But every one of those videos is just so good. And he's like such a good drawer. I wish I could draw like that. I haven't read The Art of Computer Programming really actually. I think I have a copy of some of it. No, you know what? I might be thinking of the C programming language thing. No, deadline is Knuth was talking to his publisher about when the book would be done, and should I just play it, dude? It's so funny.
It's widely used in academic document preparation, especially computer science and mathematics. I used it to typeset my thesis, human text, and fascinated in it, and not so good at generating the first time, but very thoughtful. But he did one time make a dedicated video explaining all his mistakes and correcting them. And I'm like, that's perfect. So I click on this link, which is a real. And in fact, the LLM is quite well suited to
Oh,
doing
it's
that.
right here.
Just wondering if you have an update on when 4C will be ready or any more chapters. I am working diligently on chapters for Volume 4C. As I've mentioned in the past, it's impossible to tell how long it will be, since mathematics does not obey the rules of project management. I just need a date to tell the publishers. Like I've said, any date would be very low confidence, other than the fact that it will be in the future. I just need a date. Would you like me to say a date, knowing that it's a very low confidence guess and that I would be extremely likely to miss that date or even deliver early? Early? Now we're talking. What use is the date if you're excited about the possibility of it being early relative to some unknown date? I just need a date for the
That's
publisher.
the funniest thing in the world to me. Oh my goodness. It's early, but it might be in 100 years, man. Oh my god, that's so funny. Corman? I don't even know what that is. Is that ICLR? CS text book? Oh yeah, yeah, ICLR. Yeah, yeah. I would kind of want to buy this, but it's like 1,000 pages long, dude. Yeah, all these books are kind of boring. Actually, you know what I've been reading, dude? You probably like this book. It's Introduction to the Theory of Computation, bro. This book rules, man. I have been freaking loving this book, dude. Find it for free online, I think. But this book is really good. I honestly, I did like a bunch of the exercises up to maybe like chapter 5, but now I'm going through and I'm just doing every single one of them. Yeah, maybe I should get myself a copy. I have the PDF, but I love collecting the books. Do you get the physical books? Yeah. Damn, that's gotta be a fat book, dude. Hold on, I gotta cheat a little bit, see if I did this thing right. Where's my other? Oh, here it is. Hold on, let me get my chat up so I can see it. Dude, oh, man. I think I played a little too much. My wrist's a little weak. I haven't been able to play in like 3 weeks now. My wrist has just been killing me. I'm going to the doctor tomorrow. Kind of sucks, dude. But I did run like 7.5 miles today, so I still getting exercise, but you know. I know, me too. Me too. I think it's getting better, but I just really don't want it to I really don't want it to like get better, and then the second I start playing tennis again, it hurts again. That would be the worst. So the left spring, they're saying it's y minus. Oh, so I got it backward. Oh, that's great, dude. Yeah, I'm really bad at lifting weights. I definitely prefer like cardio. That's good though that you do it every day. Oh, because they always do minus. But is that right? Because then it'll be. Let me just see. So plus K1. Oh, wait. Let's just do this. What is that on the bench? If you can bench 135, that's really good. I can only bench. When I was going to the gym a lot last year, that's really good, dude. I could only get to. I think the most I ever did was like 90 or something. So if this is like minus, but okay, so wait, let me just. Oh no, I did this wrong. So this is fine, but I was trying to derive what f equals ma and f equals kx. I for just the left spring, I had mx double prime, or we'll do y double prime. It's equal to kx, but we need to. But if we make the origin. Oh, that's sick, dude. Except for that second thing you said. That's weird. But getting stronger, that's great. Um, if we make the origin left wall, then shouldn't we have my? Oh wait, let's just do x. X makes way more sense because it's on the sliding horizontally. You know what's crazy, dude? I realize I've never seen your face before. Isn't that wild? Dude, I don't even know what you look like. You gotta send me a selfie. Um, so shouldn't this be k times, or we can do k1 times, and then this is gonna be L1 minus x, because if x is greater than L1, then the acceleration will be negative, right? Or is there a convention? I don't know. I feel like it's a convention thing, but let's see. How many problems do I have to do? I have this one's will be done, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh shit. Damn, I'm gonna be doing homework until fucking like Okay, wait. You're right. If you place the origin at the left wall, then when spring is stretching, it should pull back negative force. Right. But Hooke's law says this force of the spring is negative. Wait. Since the current length of the spring is just x, the extension is x. Hmm. The extension is x minus L1. So if x is before, to the left of it. Yeah. So this is the same thing. Okay, but let's keep it to how they typically do it. Because this is, I do see minus kx more than so this is going to be x minus L1. And then this is going to be minus k2 of x. No, but you know what? This is wrong because it's going to be the force acting on this. Let's see. The deviation from it is going to be isn't it just going to be x minus L2? Where does the 1 minus x come from? Oh, because this is the rest length from... Okay, so, yeah, so... Yeah, because the thing is, L2... Alright, that's what I never understood. L2 is the distance from the right wall. Okay, I get it. Okay. So we can, this... Okay. Model the left spring force. Oh wait, I also want to do page break. So we can just get rid of this. Or yeah, this is fine. V minus kx is equal to this. Okay, so yeah, so this equation means that if x greater than L1, the force will be negative and the spring will pull back. Okay. For the other oscillator, since L2 is the length from the right wall, then the position to the origin of L2 is 1 minus L2, because 1 minus, yeah, that makes sense. So we're going to get minus K2. The force would be if x, so we have, if x is less than 1 minus L2, we expect the force to be positive. So shouldn't it be, so it should be x minus 1 minus L2, right? The sum of the forces gives us the coupled equation without damping. So we should get, let's just rewrite this thing. So we should get that the mx double prime is equal to, oh, we should box my answer. He always likes boxing the answers. There's like a weird way to do this. I actually really hate this thing, but it's like, I think it's like rect, and you do like this. No, I think it's like this with these guys. There you go. And I can also do it for down here. Okay. Gotta hurry this thing up, man. So, all right, so let's just delete this because, so we're gonna get minus K1 minus this. Okay. All right. Now we add in the damping force, which, since the damping force is based on the velocity, Okay, yeah, for sure, man. Yep. Just on that grind. It's nice talking to you though, man. It's been too long. We gotta play some Factorio sometime, bro. Oh, you too, bro. Man, I gotta get done with these classes so we can get back to chilling, dude. Oh. So okay, this force is proportional to the velocity, which is x prime, and should resist accelerator. I don't get how to see that the so we gotta do rect this, I think. Wait, oh, you gotta put a hash there. So, oh, but I hate that it doesn't center it. But I think if you do this, then it works. No, but I think you, okay, maybe it's that. No, but I think that this messes with the freaking, bro. Oh yeah. Okay, so, where did I say that thing? Okay, so this is gonna be, yeah, see that? What the hell is that? I need to ask on Discord what the hell that is. It's so annoying. Because if you do it like this, then you don't get the, um, and then this is going to be plus is equal to 0. I'm pretty sure that is the correct system. Plus k1 y so 1 x minus 1 minus L2. All right, good. So we did that one. So that is all good. Now we can go to section 2.4. But I really need some food, man. I'm freaking dying. What should I make? Okay, let's do a page. Oh, wait, we need to do this. I don't even think I need my name, but who knows? Page break. All right. So we need to go to section 2.5 and scroll up. What are we doing? We're doing 3 and 13. All right, I want to do that numbered equation thing. I actually kind of like that. That's kind of fun. All right, so let's copy this. And then let's do this. But our equation actually has a thing in it, and then we can do this, and it's going to be dv x of t is equal to 2x plus 2y. Then we have dv y of t, and this is equal to x plus 3y. Okay, and then this is numbered, but we don't want it to be, well, okay, when we transfer it over, oh, but that's going to be kind of weird. Can't I just specify the actual number? I don't think so. That's okay. I just didn't want to make a bunch of documents because it's so annoying having to, I mean, I just don't like their UI. They have some annoying UI things. Okay, so in problem 3, determine if, oh, how do we do bold? Wait, but I only want this to be bold. But this bold is like italicized. Do you see that? I don't really like that. Okay, I'll be right back. Alright, let's do this. Alright, let's do this thing, man. So, you know what? I don't even care. But why is it italicized, you know? Bold font style in math. In markup mode inside. Oh, really? Thanks, bro. Wait, hold on. In markup mode. Inside brackets. What are you talking about? What? Surround with, or do I, are you talking about like out here? Oh. Oh, I see. But okay, okay. But well, how, okay. That's actually really annoying to write though. I'm never gonna write that ever. That's a pain in the ass. Wait, but I don't even need, oh, I don't even need this. Oh, okay, that's not so bad. I don't know. Still seems like it kind of sucks. I don't care. Determine if y of t is a solution system. All right. So the solution is for x of t, y of t is equal to 2e to the t minus e to, oh, this is the worst, bro. 2e to the t minus e to the 4t, comma, minus e to the t plus e to the 4t. Is that right? Let me zoom in. Where's the zoom? Two e to the t minus e to the 4t minus e to the t plus. Okay, cool. So okay, so let's just take okay, so then okay, so we're gonna get let's say this. Take the solutions. And we get okay, plug in for the system, and let's just copy this bad boy. Okay, this is going to be this 2x 2 times 2e, yeah, okay. Okay. Oh, all right. And then for the other side, we get this. Okay. Okay. Let's do this. I don't know. Okay, so then we get simplify. Just copy this, I guess. And then this becomes 4 minus 2. This becomes minus 2, 2. Okay. Is that right? Oh my god, I can't even read this, bro. It's so hard to read this stuff. 2e to the t minus 4, 14. I did something wrong. It's so much easier to write this down on paper, honestly. I don't know why I torture myself with this fucking stuff. Do they have a simplify? That would be actually nice if this thing just had a little computer algebra system built in. Okay, wait. Let me do it on paper so that I know that it's either right or not right. Or actually, you know what? I don't actually care. Because I think that this is not satisfied. And we get 0 is equal to minus 2. Oh, wait, is it minus 2? E to the 4t. Thus. Okay, then we can do this. Was it hash rect? Dude, I don't know why the rect thing seems to just wreck my formatting. Okay. Like rect inside one of those equations is just broken. Minus 2e. All right. So that was the whole problem there. Now we do 13. Okay. 13 derive the general solution. And then we are going to do this. We're going to generate this with Python though. All right. So let's do it. So it's just, oops. Okay. Problem 13. And then we're going to do this thing again. But actually, you know, I don't even need to refer to it. So I'm just going to copy this. And we get 2x minus 8y squared. And then this is minus 3y. Okay. A derived with solution. Okay. We quickly see that the decoupled equation for y for dv of yt gives us y of t is equal to c, or let's do k1 e to the minus 3t. All right. And I forget how to do these. Let me show you, like, read this thing. Or yeah, let's do K2. That makes actually more sense because it's on the second equation. Okay, then you substitute into the first. Oh, and then you get a linear in x equation. Okay, which we can substitute into. So we're gonna get this, but we can do minus 2x. I don't know if we want to use integrating factors or what, but we're gonna get minus 8 times all of this squared. All right, so let me just do it on paper. So you get x prime minus 2x is equal to minus 8k2 e to the minus 3t all squared, which is equal to minus 8k2 squared e to the minus 6t. Holy shit, I've totally forgotten how to do the guessing. Let me read some shit. We want to, not integrating factors, we want to guess. We're trying to guess the particular solution. Oh yeah, okay. Right. We can copy this and we get k squared e to the minus 6t, and then get rid of this crap. We can use the guess x of t is equal to k1 e to the minus 6t, and plug in. So we get x prime of t is equal to minus 6 k1 e to the minus 6t. Okay, so we have this becomes this minus 2 this. And we find that that minus 8k1 is equal to minus 8k squared. Is that right? So we see that minus 6k or minus 8k1 is equal to minus 8k2 k2 squared k1 equals k2 squared. So then I always forget how you're supposed to do this. So what should the, what was the problem again? So the general solution, well, that's the particular solution though. Oh my god, dude, I've forgot all this shit already. It's harder to do it on tech than or on Typist than it is to just do it. So what did I guess? I guessed k1e to the minus 6t is a solution. If k1 is equal to k2 squared. Oh yeah, wait, hold on. I forgot about this too. Um, this is going to be just e to the 2t, right? Or yeah, let's let this be like alpha. Right, because if we have x prime is equal to 2x, then we get dx dt is equal to 2x, ln x is equal to 2 dt. Then you integrate this, is going to be 2t plus c when you integrate. Then you get x of 2t plus c. This goes e. This just becomes c. All right, so we'll call it k1 the homogeneous times e to the 2t. Okay. All right, this is all working out. This makes sense. Okay, so then what do we do? K1 e to the 2t plus k2 squared wait. So the particular solution is, no wait, we can do this. XH. So let's first just do XP, and we can get rid of this. XP, what did we guess? It's going to be -6. Oh, no, it's just going to be K2 squared e to the -6t, I think. Wait, X, here we go. So we're going to get the general solution, which is x1 or k1 times e to the 2t plus we got to double check. All right, cool. So we did that one. Now we just need to do part B, which is find the equal. Damn, it's already 8:30. I'm gonna be doing this right till midnight. From equation 2, we can see that all fixed points require y t equal to 0. Then for 2x minus 0 equal to 0, we see that x is equal to 0. Thus, the only fixed equilibrium point is x of t, y of t equal to 0, 0. And we should do hash left. Okay, cool. I think that's the, wait, no, we have more. Find the solution that satisfies, okay. Um, x0, y0 is equal to 0, 1. Okay, so that means that we take our system here, right, and we go 0 of 0 is going to be equal to 0. It's going to be equal to 1. And this is going to be equal to times 0 to 0. So this is going to be, and then this is going to be to the 0. And this is to the 0. So this gives us the equations 0 is equal to k1 plus k2 squared, and 1 is equal to k2. Is it just k2? Yeah, just k2. So then, therefore, k2 equal to 1. And k1 equal to minus 1. Okay, then we get the system. So we can copy this. And this is going to be k1 is minus, k2 is 1. So it's just going to be e to the, and this is going to be 1. So that's the whole thing. Minus, or e to the minus 6t minus e to the 2t, and then yeah. Cool. All right, and then part D. Actually, I wonder, can I just like take a screenshot? The Desmos vector field. Because isn't that what it's asking for? The phase portrait? What are the axes of a phase portrait? Alright, let's just try to run it ourselves. What? I feel like I do this every single time. How much other shit is in here? Okay. What? Why didn't it change the bounds? What? How is that even possible? What? Is that not what I'm supposed to do? How many do we have left? We have, hurry up. Too long. There we go. Now it's working. Can I just paste an image? Phase portrait. Done with Python. This is going to be, sure. And let's just double check with this. So this is going to be F1 is, what's our system originally? 2x minus 8y squared minus 3y. Perfect. Okay, that looks good. All right. Homework 7 is done. Right, that was it, right? Okay, good. So now we're doing homework 8. Let's copy. Okay, 3b. This is 2.5, right? Oh no. Hey. Dude, this is the coolest thing ever, man. Get a couple more steps. Okay, what's 7? Oh, yes. This one's going to be easy. So we just have one homework section left. Oh, it's doing this thing where I don't see the plot. It's so annoying. There we go. Oh, but you know what's going to be annoying actually is all these images are going to be local to this document. That's a little annoying. It is nice you can just paste the images in. I like that. All right. Cool. That's 7. Okay, 2.6. Number 8 is suppose y1 is a solution in the autonomous system. Show that y2. Oh yeah, how did we do this again? It was the same thing. It was the chain rule. Okay. All right, let's look at all the ones we got to do. This is 2.68. What are the relationship? Their time shifts. Okay, 11 Um, oh, this one was crazy, man. 11 was actually really cool. I would never have gotten that on my own. It basically, use the fact that it blows up faster than x squared plus 1, whose integral is arctan. And then you say, well, arctan blows up in finite time, so this thing must blow up faster than finite, faster than arctan, which is great. Okay, then 2.7, 2.7, 3 and 8. These ones are annoying, I think. Okay. This is actually a pretty good review. I haven't done, I totally, after the exam, I like totally forgot. It's like I dumped it. Dumped my thinking. And I don't think I did any of these. All right, let's just do it. Oh my god. Can you do this? Nah, so you can't even do that. That's why that bold thing is stupid. So, bold y to t equal to bold y 1 of t plus t naught is also a solution. Okay. So we're going to get this is equal to, it's going to be like y prime like f of g of x becomes f prime g of x g prime of x. Okay, where, and this is going to be g of x equals t plus t0 and bold y1. So this is going to be bold y1 prime this is going to be g, which is t plus t0 times, and this is going to be just g prime, which is equal to this right? Bold y1. It's like, Jesus, how the fuck do people do this thing? Bold y1. Oh my god. I can't believe people write books. Oh no, that's nuts. Gotta go bold F, bold Y. Oh, actually, is that impossible? No, yeah, you can do that. There you go. Oh, and I forgot, of course. How could you forget? Oh, did I box my solutions in the other ones? Oh yeah, I did. Okay, cool. You want to bold? I know, but it's like how the let. Oh, that's nice. Ooh, that's actually kind of nice. Thanks, bro. Wait, how do I? Can I copy that? Let bowl. So then I could just do like That's pretty cool. I don't know how much it saves me, but that is kind of cool. Okay, what? Wait, hold on. We gotta go like this. Do these backslashes work here? Okay. So we did 8A and B. So now we just want to do a page break and then do 11. Okay. You know what I wish, dude? I don't know if you're like in the community for Typst, but why are language models so it's like you can't even use them for Typst. It's like it almost makes me want to just use LaTeX because at least they can generate LaTeX. Because it's like, am I really gonna spend all day just writing letters? It's just brutal. X squared y squared. Okay. I wonder if you can download specific pages. I guess you can't. Okay. This is useful because we consider the scalar differential equation dv x of t is equal to x. I know they don't. I know, but it's just like it's like even if I like guide it or tell it like because okay, new models can read the docs. I can send it a link and I can even copy and paste the entire documentation, and somehow it still fails catastrophically. Let me just do a desolve. Desolve. What is it? X prime of t is equal to x squared plus 1 x. Oh wait, we need to do this. So t. And then what do I provide? Do I just do this? Yeah. It would be cool if there was Mathematica support. Uh, x of t is equal to, and what is it exactly? Tan of t plus c1. Below, below up. I mean, but it's like the worst generations I've ever seen. I don't know. There's something about Typst that it just like, I don't know. I guess there's just not that many. Because the thing about programming languages is that there's so many programming languages that it can kind of interpolate maybe, but there's really only tech. Like there's nothing else. So maybe it just fails so catastrophically. It's hilarious. Uh, which blows up in finite time. At what is it? Pi over 2. Desmos. I think it blows up at finite at pi over 2, right? Yeah. Oh, this is a capital pi. Pi over 2. Isn't there a way to do? Isn't there a way to like get this pi so that it's like? Isn't there a way to make it like sideways? Is it like this? I swear there's a way to like sideways frac this. Is it frac? No, there's some way to like fractions side by side. A local phenomenon. You've been coming in really clutch. If you know this, let me know. I want it to be pi divided by 2 in line. I swear there's a way to do that. Oh, yeah. There you go. Wait, wait. Oh, wait. No, it's going to be like, wait, this isn't right. This is like, that's not right. All right. I don't care. It's fine. Um, therefore, uh, in our system of differential equations, x of t only grows at least as fast as x squared plus 1. Therefore, it must blow up. But I don't think that's the only. I don't think that's the only part of this problem. Oh yeah, it is. Oh, there you go. Yeah, you got. Yeah, okay, you gotta escape it, right? There we go. Okay, so that was 11. Okay, so now we gotta do the freaking zombie models. Okay, 3. Problem 3. Okay, so first let's just transcribe the SIR model. Okay, here we go. Oh, let me number this equation. This is actually probably good to number. Equation. Let's do this. Oh. Oh, shit. That is not what I wanted to do. Okay. Wow, Alt Scroll takes you back? That's terrible. Alt Scroll should be like VS Code. It should scroll you fast. All right. Wait, where are we at here? We need to, so this is going to be, but is this the, we still need a page break it. But what number is it? It's going to be 2.7, number 3. Okay. I don't want to do that. Just do. Wait, Bitcoin? They have a Bitcoin thing? What the hell? Okay. Um, so this is the SIR model. We got the numbering. Okay, now we can read the problem. Okay, so okay, the initial conditions if BI is greater than ASI. So what that means is that S needs to be less than beta over alpha. So for part A, we get this bad boy. So this needs to be, so 0 is greater than this. So then we get BI. Okay. Then we get BI. And then we get B over A is greater than S. Can I do it? Let's see. I hate that rect is broken inside of these. Rect, like, I don't know, maybe, do you have to nest? Actually, do you need to nest more dollars? There you go. You need to nest more dollars. to guarantee that I prime is less than 0, we find the following inequality on S. For given values of alpha and beta, what fraction of a population must be vaccinated before a disease arrives? For the SIR model, oh man, I'm getting sleepy. For given values of alpha and beta, what fraction of a population must be vaccinated? Shouldn't it just be the other way around that okay, well let's say V is the amount vaccinated. So then 1 minus V is equal to S. So if we have 1 minus V is less than B over A, then it should be V needs to be greater than B over A plus 1. No. 1 minus B over A. Alright, let's double check our answers. Susceptible. Okay, so we did 3. This one's 2.6, and then we need to do 8. 2, so page break, 2.7. I literally already forgot it. 8. All right, number 8. So this is minus ASI. This is gone. Oops. This is gone. Minus gamma S. Actually, let's just do C. I'm not doing freaking Greek letters. Bro, calculate the equilibrium points. Well, we know that. Let's see. Minus ASI equals 0, and A. Let's just factor out the S. So we get S times AI minus C. So if I. So I can't be 0 unless. So 0, 0 is definitely one of them. But I think we need I is equal to gamma. Or no. We need I is equal to C over A. So if S is 0. Oh, wait, hold on. No, yeah, so it's S equals 0, I is anything. I is free. Okay. A. Calculate the equilibrium points. Notice that even that in S prime, we see that either S equals 0 or I equals 0, assuming non-zero parameters. Okay? But in I prime, we see How are you supposed to write that when you have, I don't know. To fix the weird rect thing, you can add this line at the start of the show, set text, bottom edge bounds. I'll try that. Let me try that. Let's see. Are all my rectangles chill now? My rectangles. Oh, that looks good. I don't know if it looked like that before, but that looks pretty good. I like that. I don't know what you did, brother. I don't know what you did. Dude, I feel like they just updated 04 Mini High and it sucks right now. Dude, it's doing so many stupid things. It's doing so many stupid things. Alright, but luckily, what do we have? This is not the last section, though. I really wish this was the last section, dude. Wait, why does I have to be greater than equal to 0? Oh yeah, because just the nature of the solution. This needs to be cool. Okay, so now we need to do part B. Ugh. Find the region where. Okay, so for I. Okay, so di is greater than 0. So we have 0 is less than ASI minus CS. S times AI minus C. Okay, so here, this one's pretty easy. So we have this turns into this, which is 0 is less than this. Okay, then we get, S times AI minus C. Okay, but then since S I are either or greater than or equal to 0, since it doesn't make sense to have a negative proportion of the population. This means that I prime is greater than 0 when S greater than 0 and I is greater than C over A. So we can just do rect. Oops. Cool. And then finally, oh, and we gotta sketch this phase portrait. That is just great. Okay. I really wish this was the last section, man. I don't think that's right. I think this code is wrong. I think it's right. Okay. It's gamma over alpha, right? Okay. Is there anything else that it said to do? What does the model predict for the spread of zombies in this case? So if okay, then we did it. Good. Okay, so that is 2.7.8. Now we just need these two. Oh, wait. All right, so uh X, a Y, a Z. Okay, we have sigma y minus x. We got rho x minus y minus xz. And we got minus beta z plus xy. All right. The Lorentz system. The Lorentz system. Or how do they typically do that? Not with a space, with a comma. Okay, so for this one, oops, we got this, except this is going to be 0 minus 0. X is 0. Y is 0. This is 0. So we can say equal to 0, equal to 0. And then this is going to be 0, 0. Okay. Find the solution with the initial condition. What does that even mean? How do you find the solution? Granted, I didn't even read this section, but how do you find the solution? What is that? What is that? Oh, the solution with initial condition. Okay, so then uh, B, the solution when the initial condition is zero. What is it? 0, 0, 1? 0, 0, 1. We get the system. Let's do this. This might be better. 0, 0. This system has the solution. The x of t is equal to 0. Y of t is equal to 0, and z of t is equal to this. Is z of t is dz dt equals minus beta z. So it's going to be ce to the minus bt. Beta is 8/3, right? Oh my god, it's taking so fucking long. Okay, the solution when we have an arbitrary wait, we can but this is gonna be like this, but it's gonna be z0 like that. Okay, I think we finally did it. Now I just have to do a bunch of crap to get it into a submittable form. But I think let me just go through and make sure that we have everything. 7. How do I jump to it? 9. 3 and 13. All right, I'm gonna end the stream and I'm just gonna like transfer everything over. All right, peace out. Thanks to Local Phenomenon. If you're still here, bro, subscribe. You helped out a lot. Thank you.